Next up, we will have Anthony. He'll be presenting, he'll be having a presentation on the artificial intelligence that can be used during the formation of the FMEAs. And AI is obviously becoming a huge part of, this new product development process. So being able to utilize those tools in the FMEA creation is a powerful tool to use. So Anthony will be presenting this, and he's our VP of Global Operations for Omnex Systems, overseeing our software and our North American sales as well. So please give a welcome to Anthony, and we'll let him present.
Thank you, Andrew and Andre. Good afternoon, everyone. So the topic that I'm going to cover is on AI in FMEA. All right. So we'll talk a little bit about, what is the FMEA solution expectation today? I mean, this is something we've been having FMEA software for the longest time, and there are already some preset expectations of what an FMEA should have. And I'll talk about that before we talk a little bit about AI. Let's level set AI a little bit, because we talked a lot of digitalization ideas, the whole day today and some part of yesterday. Let's talk a little bit on AI and what AI can do and what it can offer. And why do we need AI in FMEA? What's new about it? How can the FMEA, I'll show you some videos on FMEA validations and recommendations. How do you train the bot, and what are the benefits that you're going to get out of AI? So before I start the presentation, what do you think is common between all these images? I mean, take some guesses, take a shot at it. Okay. Sorry? Okay. Okay. Machine learning, okay. Sorry?
4 squares.
Okay. But interesting is that these are all images created out of an OpenAI DALL-E 2. It's a text to image. You can give a text to this AI application, try it, and it's fun. Okay. I tried a lot of things before I got this image. That's a different story. But it's a text to image where you can give it a text and it'll create an image for you like that. Okay. Exciting, isn't it? So let's get into the AI journey here. So you saw the digitalization concept, and we've been talking about these different platforms and how each of these platforms are going to help. So when we look at FMEA solution, the minimum expectation is that, hey, we need to have family of parts, right? You have to support the V model. And of course, I want to have the bill of material information inside the system. That's the minimum that we need today, right? Because we've been talking about model-based engineering, we've been talking about V model, we've been talking about reuse. We need the structure in place, right? What else do we need? We also want a lot of information to be reused, both from between families of family and part numbers, right? So if I have, say, for example, a battery module, and I'm making like different variants of that, and I have part numbers specific to that, I should be able to, learn from the best-in-class design and best-in-class process, and able to reuse that information between families of family and part numbers. Okay, so it's the reuse of requirements, it's a reuse of failures, it's a reuse of preventive and detective controls, all that already built in. From an operational and functional, from an efficiency perspective, when you get to a part-specific document, most of your document is already inherited and it's given to you, and it's prescribed, right? And then you're only filling the specifics that's specific to the part, right? Now, the other expectation is being able to reuse libraries. I'm showing you an example of a process library where it could be a design library where you have, set of your design test requirements, your design validation requirements. They are already in place for different products, and you're taking that from that library and reusing for different products and families. Right? Here's an example of a process best in class where your product goes through very similar process, and you build your process libraries and then reuse them for different product lines, and using the previous slide concept applied at the family, then it automatically inherits to the subfamilies and the parts underneath that. Okay. Now, whatever I'm showing you are expectations since the 1980s, I would say, right? Because we always had it, and we know users wanted it. Compatible with different types of formats, right? Many of you here are not just only supplying to automotive, we are also supplying to aerospace, you're supplying to medical devices. There are different standards that you have to apply. Like aerospace has still not fully embraced the AAG VDA FMEA yet, right? They're still in the 4th edition. So you need variety of format. The last one there, the multi-point FMEA, that's a big one where with products becoming more mechatronics, you now need to support multi-point fault, which links to your FTA and so on. So these are all expectations that we have, and of course, be able to build off reporting out of all the FMEA data. That's the whole reason why we are digitalizing all this information. So you can process, analyze, make informed decision. This morning, Rebecca was mentioning that, what it used to be a 3-day haul of understanding what is my risk on these products. Now it's become 45 minutes just to be able to say where the product risks are and immediately take actions, right? So just for everyone, Pete, I didn't get the memo, so I didn't get that trajectory graph. So here it is, a little bit different one with so where is FMEA going with this, right? So it started with the DFMEA PFMEA linkage. Then the AAG VDA SAEJ 1739 released a version 2022 January. Multi-point failure linkages, talk about DFMEA, FMEA, FTA linkage. The next trajectory where we see FMEA going is, getting some support from AI. Why? Because good news is we have data, all right? And the better news is technology has matured, all right? So what is AI? We talked about AI quite a bit. It's a way you're using advanced algorithms and natural language processing, machine learning process to automate and make decisions. So there are two fundamental things that AI usually does. One is able to validate. The second one is able to recommend. Okay. I'm going to talk about generative AI in a second. Let me not get ahead of myself. So AI has been in the industry, I want to say, since 1955. Okay. It's older than Microsoft Excel. Right. Microsoft Excel is 38 years, I think, and AI is 1955. That's about 58 years. So that AI is that old, and the technology has evolved over time because it was initially used in a much smaller space of robotics and so on, including strategic game building. Autonomous vehicle has taken AI to a whole new level. Okay, it's probably the AI is going to be at the best at autonomous vehicle because a lot of instant decision making has to be done, and there's going to be all kind of technologies thrown at an autonomous vehicle, from on a street, understanding the speed of that you need to drive, the lanes, understand there is work in construction. That's all OCR processing. And the second thing is GPS. So it needs to know where it needs to drive itself. It needs to understand all the functional safety sort of requirements. At the top of the line, AI is going to be an autonomous driving. Okay, that's the excitement we have. But AI has also helped, with us every day. I mean, without knowing, and you are touching AI every single day. Alexa, Netflix, Amazon, they all give you recommendation. You talk to them, Siri, right? Just to say that, hey, you want to set an alarm, you're already talking to an AI application, right? So AI has been there forever. Now the new excitement that we have was started with artificial intelligence, machine learning, deep learning. So what's the difference between machine learning and deep learning? Machine learning processes rules. Okay, these are not like your if else, do this. How many you're seeing all your emails, right? Day to day, you're seeing emails. How do your emails get tagged as spam? Have you ever thought about it? That's machine learning. All right. So it does not use the sophisticated deep learning algorithm, but it uses parameters in that to actually say if that is a potential spam or not, and it uses machine learning for that. So there are machine learning rules like that. The deep learning algorithms are like human level processing where it can process, the one that I showed you, like text to speech. So you can type something, or you throw a web document, it will read it out for you. So all those are deep learning because it's processing human language. Right? The new one, the large language models. You saw Meta first launched a Meta, that's WhatsApp and Facebook. They launched their first large language model. It's called Lambda. Okay. And then after that came ChatGPT 3 was still using Lambda. And then by 4, they had their own large language model, which is ChatGPT 4. Okay. Google AI has a BARD, which is another large language model. All these large language models are pre-trained and pre-processed, and it can generate a lot of AI. So it'll actually generate content for you. So that's the new age deep learning. It's called generative AI. I put it right in center of deep learning. It's a little bit of machine learning, deep learning, kind of a cusp area. So don't quote me on that, but yeah, there's a lot of argument around where generative AI is, right? It's kind of doing a little bit of both. So why do we need AI in FMEA? Okay, number one, same idea. Virtual product development teams. Your product development teams are no longer together. Nobody's looking over the shoulder and helping, or at least you're not meeting together to talk about how do I come up with a better FMEA, right? So next, the emergence of the millennial workforce that we talked about. Right? They are coming in brand new, and they are trying to put a FMEA that's going to go into an autonomous vehicle. Imagine that goes to your brain system. All right. So, one line of code. I saw somebody talk about that this morning, like few lines of code. Oh, it was Brian News yesterday that few lines of code could be a disaster, right? So we are also seeing, AI as one of those utility to help with product complexity, able to be that guide when you have more complex products. Learn it in the first launch, but then reuse that information for future launches. Knowledge management. I told you the experts that we have. How can we take all that knowledge and train it into a bot? So the bot is being the co-pilot or the expert or the subject matter expert when someone is actually building these documents. Of course, reduction in cost, errors, warranties, all that AI could help. So I talked about two types of FMEA. For the FMEA scope, we have two types of rules. One is validation, right? I'm listing all the the different types of documents you can process. Today, we support the AAGVDA 4th edition, the process flows, control plan, all these documents today we support. And it comes with pre-built machine learning rules. So you can run those rules on your documents. I mean, I'm going to show you some videos on how you can run it on our AquaPro FMEA tool, and it actually gives you all this learning. Okay. The second type of FMEA AI you can apply is a recommendation system. Okay, so the best example for a recommendation system is Netflix. Right? When you have watched a movie, right, it automatically starts to process, different movies on the genre, the type of actors you have, directors sometimes, and then it starts giving you a recommendation system. Okay, now these recommendation systems are very user specific, right? Like, for example, in our home, my wife and I both, we have separate logins, right? So my wife watches a lot of Korean series. When I log in, I can't believe I'm still seeing something there. There's a lot of Korean series right there. Okay, so the recommendation is very contextual for the user. Okay, the same logic is applied in FMEA, where the recommendation system will apply or recommend, like, for example, failures or severity ratings based on the context, of the product. Okay. All right, let's see those. I'll give you a moment to take some questions if you have to write down any questions. And I'll run this video here. Okay. The first video we're going to run is for recommendation system. This is the idea of a coach, new teams, existing teams, newer product. AI can actually be there as you are working on this FMEA documents. Okay, here's an example of somebody trying to add a new row. This is an example of a PFMEA, but doesn't matter. The format doesn't really matter. So when you start let's say you pick a characteristic, it'll actually start giving you recommendations of what is the right potential failures. From the database of failures, it's recommending you, sorry, it went a little fast. Okay. Can you see from your list of database, it's actually giving you recommendations on what are the top potential failure modes. And this is based on the training that you've done to the bot. Okay. So your products are going to be unique, right? Each of your products will be unique, and the failure modes could be unique, and system, based on the training, the bot will actually recommend you the right type of failures. Okay. Once you go in and start picking a failure or effect, they'll actually give you what could be the potential rating for that. So it actually shows you that this is one of the rating. When you add the second rating, you see that now based on what you pick as an effect, you will see the bot give a whole different rating for that. Allow it to pick. All right, look at that. Now it's actually based on what you had picked as a cause. It's giving the user a different rating. So it's contextually giving you a recommendation based on the product, from the product to an operation to a characteristic to a cause, all the way to an effect where it is dynamically saying that, okay, hey, that's one of your potential rating. Okay. So the recommendation continues throughout the rest of the document, saying that when you add a cause, it gives you what are your potential occurrence rating, because these are things that the users don't have visibility. They're not sure what should be my rating, right? And the AI bot will actually help you with that. So now you're trying to add a preventive control, and it gives you a recommendation for that. Okay, so the recommendation, I don't know if you can very clearly see. Now I'll pause it for 1 second. Everything that's highlighted in yellow is giving you the best case rating. Okay, where is this coming from? This is coming from the training that you do to the bot. Now you already have FMEAs, right? You have FMEAs, even if you have them in spreadsheets. So when you're transitioning from, let's say, even spreadsheets to the digitalized software, your previous learning can be used to train the bot. Okay? Because bot, all it requires is a set of data to say, okay, what is good data, what's bad data, right? Once you have both, you will be able to feed the bot with that data. Give you another example of a validation system. So let's say when you're opening a DFMEA, you have an option to say validate it, and you can say what is my focus element and context element. And when you run the validation, it's going to process the entire document and give you feedback. Okay, so the user is going to now say, hey, help me validate this document. Now, why validate this document? Because you don't have to actually formally send it for an approval. Even before you send it for reviews and approvers, as you're working as an engineer working on the FMEA, you can ask the AI to process it for you. Okay. Oops. So for example, it's saying, hey, you're missing some of this critical information in this document. It's missing some model numbers, your FMEA team information is missing. This is with limited what do I say, rules that I have, but it could be all the rules that you want. On the right hand side, can you see it's saying that there is detection action, but the responsibility and target dates are missing. So it's highlighting the detection action, and you're saying, hey, there's no responsibility or target date associated. These are simple rules, but when a new person who's coming in and trying to send this FMEA, imagine the effort that is actually on the reviewer to go through all this, catch all the mistakes, and then pointing out simple ones, which could actually be caught by an AI solution. Yeah. Continue to run this video. So there's a detection missing, it's giving you feedback. I think there's a prevention action. You have an action, but there is again, so if you, for example, if you had an action responsibility and no target date, you'll flag it for you. Okay, so that like that, you have different types of rules. In this one, I think again, prevention action, there's something missing. You'll see another one where it has a high AP value. Right here, there's a high AP value. It's flagging an high AP value, and that's only because there is no occurrence values fed in by the user, right? So, yep, preventive controls are not there. Anyway, so just to give you an idea of all the different types, some of the rules that you can, the bot can actually help you process. So I'll recap to say there are two types of rules. One, validations, where the bot is processing the FMEA and flagging everything that's wrong. Okay. The second thing, where it's working as a guide, coach, subject matter expert, helping you develop the FMEA. Okay. So how do you train the bot? What do you need to do to actually get this application working for you? Right. Again, I'll try to give you the context of Netflix, because you would have used it, or even Amazon, right? First thing is that what do you do when you sign up for Netflix for the first time? We'll ask you, hey, give me the type of movies you like. It gives you like 5-6 different options. As you start picking them up, it starts getting to know who you are, right? So the AI engine is trying to say, okay, so Anthony likes action. He likes the rom-com, and then it starts profiling me and gives me a first profile. It's not accurate. That's where the accuracy comes. It doesn't profile me perfectly. It says, all right, 50%, let's give it a shot. And I'm more likely to pick one of those from what is recommended. And then you go about it. So it's what is called as from the AI algorithm. It's called user-based contextual, algorithms. There's another algorithm. It's called collaboration algorithm, where if you have multiple users trying to do the same thing based on different profiles, it'll actually give you some collaboration. If the AI doesn't have data. So the first step, what you do is actually it's gathering data. All right. So good thing about FMEA, everybody has it, right? Everybody has it in some form and shape. What we don't know is the good, bad, ugly of it, but there is FMEA. So we take the effort to gather the data, and you cleanse it, and then say what's good data, what's bad data. So why the good and bad data? This is just to make sure the bot also catches bad data, right? Not only missing information, but an incorrect way of writing your costs, right? So the classic column switching, cost being identified as a failure and failure being identified as a cost. So that training can be given to the bot, right? What is good and what's bad. So typically, you do what is called as a 70-30 rule. There's 30% in your training data set. 70% is usually good data, 30% bad data, and then you build that data set. Then model building and augmenting. So for the AI, we already have a model that we're using for the recommendation system and validation system, but over time, you need to tweak it. Okay. The reason I say tweak it is the algorithms every day. NLP is one technology and an area that's changes every single day. There is a new algorithm, a new tweaking that's happening. You have to be almost listening in and knowing what's happening in AI in every single day. Right. So yes, there's an opportunity to improve the algorithms and the accuracy levels of it. And then, of course, you verify the bot, do the learning, and then visualize your results. Then you continue to train the bot. Okay. It's a cyclic process. Okay. I covered this earlier in terms of how you deploy AI inside your organization. I mean, first, get your foundations, right, get your data, because AI without data, would they call it as a cold start problem? Okay, meaning cold start in the sense, if you don't have data, how does the bot know what is good and what's bad, right? So then what we do is we artificially create data. You can create data to say, hey, what is a good failure for this product? What are the potential failures? Let's say, for example, you don't have an FMEA, you have a completely new product, right? Then you can start, just like how you will work on an FMEA, you work on an FMEA and you train the data, you generate data and say, hey, what is good data? What is bad data? It's called, the concept is called cold start. If, AI cannot start processing your, the rules. Of course, you have data, you have mobility, and then fit in AI as soon as you're having the right amount of data inside the organization. Again, for FMEA, lucky, the data is already there. Some of the benefits. One is that it helps in accuracy in the PPAP development, including FMEAs and control plans. I showed you examples of FMEA, but we also have AI and control plan, okay, about validations and so on. It can help you really develop complex FMEAs through an expert guided system. That once you are able to train, you cannot physically be there in every time zone. Impossible. I mean, imagine you working in an Asia time zone at 3 a.m. and trying to help them how to build an FMEA. You don't want that, right? Knowledge management. I mean, that's something, it's also a little bit personal to me. There's a story behind that. So in my executive MBA program, I might have told this earlier too. My executive MBA, we were in cafeteria, and one of my professors, he was also he was one of the chief secretaries to the president of India at that time. So he walked in and he said, "Hey guys, what do you think about technology?" This is 2011. And he was saying, within this cafeteria on this table, we had everybody on that table had at least 10 to 12 years of experience. He said, all you guys have about 20 to 12 years of experience. I personally have a 40 years of experience. How do we transfer this knowledge to the community? That was his question. Okay. We didn't know an answer. We said, we don't know. There should be something coming later. And as somebody Googled and said, hey, there's a way where you can box somebody into an ice freezer. I don't know if you know, there are companies that do that. They freeze you at the moment of death and they can revive you. They expect that you can revive you. So we told him all these answers. I don't think he was happy, but hey, AI is the solution right here in this room. We have 200 years, maybe. I'm not dating you, but I'm not making you. Could be. That's the knowledge we have right in this room. You could train an AI bot and transfer that knowledge into it's a huge knowledge management, right? Of course, with knowledge, you can avoid errors, start predicting information, not just inside your organization, but the supply chain also. Okay. So what can AI do next? Okay. I'll leave you with this. That I asked AI, hey, can you write a poetry for me on FMEA? And it wrote a quatrain for me. Read it out. In the world of mechanical dreams and schemes, where failure is but a lurking ghost, FEMA stands tall amidst it all, a sentinel guarding our coast. All right. Failures they whisper in hushed, fearful tones of things that could falter and break. With the systematic grace, FMEA takes its place, predicting each potential mistake. Right? The last paragraph was, I had to stop it because it was just continuing. I had to stop it to say, stop, that's enough. I need to take screenshots. So the last one is interesting. Potential severity occurrence in line, detection keen eye on the fray. We rank and we score, every seeking more to keep a lurking disaster at bay. I was impressed. So the future of AI is not about writing the poetry, but could be to help write the FMEAs, right? I think that's all I had today.